Hi guys, welcome to Gatematic. In this lecture, I am going to give you the strategy to tackle double E core subject, that is synchronous machine. So let's get started. So before going into the detail, I would like to tell you that there is no any book present in which you will get 100% concept of synchronous machine. So you have two books available. First one is the PS Bhimra and second one is the DP Kothari. Okay, I am considering these two books from where you have to study all the concept related to synchronous machine. So you must have PS Bhimra or Kothari. Also, I will give you the PDF link of these two books in the description below. Okay, now let's start the synchronous machine. In all the machine, first thing you have to study, that is the basic concept. In what way it is different from the DC machine, transformer or induction machine, that thing you have to study in basic concept. As we have gone through the induction machine is a singly excited machine, right? However, if I will talk about the synchronous machine, then it is doubly excited machine. Means we are supplying voltage to the field as well as we are supplying AC voltage to the armature winding also. So it is a doubly excited machine. So you have to know about these things, about the construction. Then you have to know about the formula of electrical and mechanical degree, that is theta electrical is equal to P by 2 of theta mechanical. These things you will get in page number 246 from Bhimra book. Okay, PS Bhimra page number 246. That is theta electrical is equal to P by 2 into theta mechanical. Then you have to know about the pole pitch. What is pole pitch? Pole pitch is the angular distance between two successive poles. This is the angular distance between two successive poles and it is always equal to 180 degree electrical. Please keep in mind, pole pitch will never change. It is always equal to 180 degree electrical. However, the mechanical degree will change, but electrical degree will remain same, that is 180 degree. Okay, now talking about the coil span. What is coil span? Coil span is the angular distance between two conductor of same coil. What do you mean by this? Suppose we have rotor, okay, and it is a two pole machine. Suppose we have here north and here we have south, and we want the conductor such that the first conductor is lying at north and second conductor is lying at south. This is dot and this is cross, let us say. So what is the coil span? Coil span is the angular distance between two conductor of same coil. So angular distance will be this much. It is always equal to 180 degree electrical. Okay, in this case. Now suppose what I will do, instead of attaching conductor on north and south pole, what I will do, I will put conductor here and second conductor here. Let us say this is dot and this is cross. Now the coil span will change. This will not be equal to 180 degree, it is less than 180 degree. So coil span will give you an idea that the angular distance between two conductor of same coil. This is the angular distance. Okay, then move to the full pitch coil. What do you mean by this? Full pitch means if one conductor is available at the north pole, then the other conductor must available at the south pole, so that both conductor will get maximum EMF. That is the full pitch coil. Okay, now talking about the short pitch coil. Short pitch coil are those coil whose coil span are less than 180 degree, that we have seen while giving you the definition of coil span. So if I will put conductor here and second conductor here of same coil, then it is considered to be a short pitch coil. Okay, so these all concept you have to study before starting the synchronous machine, and these all concept you will get in PS Vimra page number 246. Okay, now talking about the armature winding. Armature winding may be star connected or delta connected, depends upon the type of machine. Generally armature winding are star connected. Why? Because we are taking output from the armature winding, electrical output from the armature winding, so there must be some neutral point in order to protect the winding in case of fault. So generally the armature winding are star connected. In synchronous machine, there are two types of rotor available. First one is a cylindrical rotor and second one is salient pole rotor. Okay, so cylindrical rotor, in cylindrical rotor the winding are distributed throughout the surface of cylinder, while in salient pole this is not the case like this. Suppose this is a rotor, okay, this is a cylindrical rotor, but in salient pole the rotor you will get like this. This is north, this is south, this is a two pole rotor. Suppose I have to make a four pole rotor, then it will be something like this. Okay, and this is cylindrical rotor. So what is the difference between cylindrical and salient pole rotor? Here the uniform air gap are available between stator and rotor, but in salient pole rotor there is no uniform air gap. Suppose this is a stator. Okay, so air gap across it along the axis is less, while the air gap along q axis is more. So overall, the reactance in the salient pole rotor is not uniform. In cylindrical rotor, the leakage reactance is uniform. Therefore, we can represent directly by x's. But in salient pole rotor, because of non-uniform nature of air gap, there is non-uniform reactance are available. Here, the air gap is less, and if air gap is less, means reactance will be more. And here, air gap is more, means reactance will be less. That you will study in salient pole synchronous generator or motor, that is the two reaction theory. This is the two reaction theory, the non-uniformity in reactance. That is the reason in salient pole synchronous motor you will see that the reactance is resolved in two categories. First one is the xd, that is the d axis, and reactance along q axis, that is xq. Okay, while in cylindrical rotor there is only one reactance available, that is uniform along each surface of cylindrical rotor, that is xs. Got it? So what you have to study in emf equation under full pitch, you have to derive the formula of emf, that is equal to E is equal to, that is the rms value, 4.44 f n phase into phi. Remember, this n phase is number of turns per phase, this is not a speed. Got it? So you have to derive this emf equation under full pitch. So under full pitch you will get emf is equal to 4.44 f n phase phi, and second is emf equation under short pitch. Short pitch I have already explained you. Short pitch is something like this. One winding is here and one winding is here. This is north and this is south. So this conductor is not at north and this conductor is not at south. So this is short pitch, means whose coil span is less than 180 degree is considered to be a short pitch coil. Got it? So if you will find the emf equation under short pitch coil, then you will get a one more factor, that is cos epsilon naught by 2. This is the pitch factor. Okay, and the derivation is already given in page number 252 PS Bhimra. So pitch factor is defined as Kp is equal to cos epsilon naught by 2. So why short pitch winding is done? Short pitch winding is done in order to remove the harmonics. Although the EMF induced under short pitch coil is less than the EMF induced under full pitch, but it will reduce the harmonics if I will do the short pitch winding. Also, conductor material will reduce, cost will decrease, and due to lesser harmonics, hysteresis loss and eddy current loss will decrease. So these are all are the advantage of short pitch winding, but there is only one disadvantage, that is the RMS value of EMF will decrease. Now talking about the distributed winding. The concept of distributed winding you will get in page number 264. So here again one more factor will come, that is KD is equal to sin m beta by 2 upon m sin beta by 2. Because of distributed winding, again EMF will not be equal to 4.44 f n phase phi. It will be equal to, suppose this is Kp, again one more factor Kd will come, where m is the phase width that is given by slot per pole per phase. Okay, and beta is given as 180 upon slot per pole. So these all concept you will get in page number 264. Go through that, and this is very important. These distributed winding as well as EMF equation at short pitch, these two are very important. You have to understand this concept in page number 252 and page number 264 of PS Vimra book. Now talking about the salient pole, leave this salient pole machine. This way I will discuss at last. Okay, now moving on. This is very important. Point number 3 is very important. This is related to armature reaction. You have to draw the flux and MMF phasor in synchronous machine under no load, unity power factor load, 0 power factor lag, 0 power factor lead, lagging load, leading load for both motor and generator. So if I will talk about the generator, so I am giving you the rough idea. The MMF will be along this, then EMF will lag behind by 90 degree with MMF. This is the EMF. Now if I will talk about, let us say I am talking about the purely inductive load. So for purely inductive load, the current will lag by 90 degree. This is the current. Okay, with EMF, this is the lagging nature. Because of this current flowing in the stator, that is the armature winding, there is flux produced, that is known as phi AR. Now see, this phi AR is trying to decrease this field flux. This is field flux and this is phi AR. So this phi AR is opposite to the field flux, means it is trying to decrease the field flux. So overall net flux will get reduced. So net flux, this is the, let us say, resultant flux will get reduced. So which type of nature is this? This is the demagnetizing type of nature. So these phasors you have to draw for both motor as well as generator. I have drawn considering generator, you can draw considering motor also. So in case of motor, what you have to do, replace this armature current with minus sign, means this, the phasor of IAR will be in same phase with phi f in case of motor. So overall in case of motor you will get the magnetizing type of nature. Got it? So these all things you have to draw. You have to draw the phasor diagram of flux and mmf in synchronous machine under different load, and this is very important. This is related to armature reaction, and armature reaction of synchronous machine is very important, and the concept you will get in page number 543 to 546 from in PS Bhimra. Okay, so study from there and make notes properly. Moving on, the point number 4 is equivalent circuit of synchronous machine. So if the EMF induced across the armature, let us say EF, then what will be the drop? First one is the drop due to leakage reactance, that is XL. Second drop is due to armature reaction, that you will study in this concept, that is the point number 3, XAR. And third drop, that is the due to winding resistance RA, and this will be my terminal voltage VT. And after making this, you have to draw the phasor diagram. So you can easily draw the phasor diagram. Only the difference in this and transformer is here one more parameter, that is the XAR will come into the picture because of armature reaction. Okay, so after making the equivalent circuit, draw the phasor diagram and you will get a concept in page number 552, and equivalent circuit for getting equivalent circuit, that is page number 559 in PS Vimra. Now sixth one is the EMF equation formula, that is also very important, and that concept has been given in page number 561. You will get a magnitude of EMF that is equal to under root of VT cos phi plus IA RA square plus VT sin phi plus minus IA x square. Okay, so this formula, the formula is already derived in page number 561 of PS Bhimra, so you can go through that. So by using this equation you will get only the magnitude of EMF. This will help you in finding voltage regulation. So voltage regulation, we know that VT at no load, that is the EMF, minus VT at full load upon VT at full load. While finding the voltage regulation, you have to take the magnitude only. So this VT at no load is nothing but E only. So E minus VT upon VT will give you the voltage regulation. So this formula is very important, that is the magnitude of E. Now talking about the characteristics of synchronous machine, this is also important from gate point of view. If I am making 3 star, then you should understand that most of the question can be framed from this topic only. So you have to know about the OCC, open circuit characteristics, short circuit characteristics. Remember, OCC is nothing but the plot between EMF versus field current at constant speed. Okay, this is the open circuit characteristics that you have seen in DC machine. But the SCC, that is the short circuit characteristics, we will find only in synchronous machine, and the concept has been given in Kothari. This is the DP Kothari page number 456. This is not PS Vimra page number. This is the DP Kothari page number 456. In PS Vimra, short circuit characteristics is not given up to that level. That's why I am telling you to go through DP Kothari page number 456. You will get concept of short circuit characteristics as well as the concept of short circuit ratio. This is very important. Short circuit ratio, SCR. Okay, so study from there. That is the page number 456. Third one is the zero power factor characteristics. You will get in PS Vimra page number 554. External characteristics, that is very important. It is drawn between terminal voltage and load current, that is the external characteristics. You will get in page number 577 in PS Vimra book. And last one is the compounding characteristics. So go through these all characteristics. The page number is already given. Only you have to study the short circuit characteristics from DP Kothari page number 456. Rest you will get in PS Vimra. Got it? Now the ninth point is very important, that is the power angle equation for both generator and motor. If I'll talk about the generator, then the apparent power for generator S is given as VTEF upon ZS, where ZS is the internal impedance of synchronous machine and theta S is the angle corresponding to ZS, that is tan inverse XS upon RS. So VTEF upon ZS at an angle of theta S minus delta, where delta is the rotor angle, minus VT square by ZS angle theta S. So you can derive this power angle equation. This is very easy. First you have to find the current I, then you have to find the conjugate of current IA star, and then in order to find the apparent power, what you have to do, S is equal to, you have to multiply by terminal voltage VT into IA star. So you will get this much. Now in order to find the active power and reactive power, you can easily find power is equal to S cos phi, we know, and reactive power is equal to S sin phi. So multiply this angle with cos phi, then you will get the active power, and reactive power you have to multiply by sin phi. So power angle equation for generator is given like this. In the same way you can derive the apparent power for motor also. So the concept is given in page number 497 to 502. All the derivation of generator as well as motor is given from page number 497 to page number 502 in PS Vimra book. So go through that. If you are not understanding the concept, then ping me on Facebook group. I will try to make one video related to power angle equation. This is very important, that's why I am saying. Okay. Now the 10th point is concept of reactive power. This is also important. In synchronous machine, most of the students don't know when the generator delivers lagging reactive power, when the generator absorbs leading reactive power. So most of the guys will have confusion in the concept of reactive power. So concept of reactive power is given in 585, page number 585 to 588. See how the reactive power, the formula of reactive power is Vt upon Xs under into E cos delta minus V. So you have to understand the concept of reactive power in normal excitation, in under excitation, and in over excitation. So if E cos delta is greater than V, then definitely it is over excited, right? So in over excited you are getting Q greater than 0. If E cos delta will be greater than V, then Q greater than 0, and if Q greater than 0 means that generator is delivering lagging reactive power. So these all concept you will get in page number 585 to 588. 11th point is V curve and inverted V curve. You can easily understand the V curve and inverted V curve for both motor and generator, and the concept is given in DP Kothari page number 482. Please remember this. The concept is in Kothari, in Bhimra, and the concept is given but not up to that level. That's why I am telling you to refer DP Kothari page number 482. You will understand the concept of V curve and inverted V curve. Moving on, this is very important. Operating characteristics. Again the concept is given in DP Kothari page number 478 to 481. Okay. So in operating characteristics, we have to go through two cases. First one is the constant excitation. Constant excitation means EMF is constant. Okay, and I am varying the load, then what will happen? So if EMF is constant, then we know power is equal to EV upon X into sine delta. Okay, and you are making E constant, V is already constant, X is constant, so P proportional to sine delta, that is the rotor angle. So if you will change the load, then the rotor angle will also change, because of variation of load the power will change, and because of change in power the rotor angle which will change. Okay, this concept you have to study from page number 478 to 481. Now the second case is constant load and variable excitation. What do you mean by this? If load is constant means power is constant, that is EV upon X into sine delta. This is the case 2, and you are changing the excitation. So what I can say? I can say EF sine delta will remain constant from the above equation. Also we know power is equal to V into IA into cos phi, and this will constant in the second case. So from here Vt is constant, so I can say IA cos phi will constant. So concept is already described in 478 to 481 page number in DP Kothari book. Now the 13th point is group characteristics. This is very easy and also important from gate point of view. Okay, and the concept has been given in page number 545. Okay, now talking about the salient pole synchronous machine, I have already explained you what is the salient pole synchronous machine. The air gap will not be constant in salient pole synchronous machine, so it can be, the reactance can be resolved in two categories, that is XD and XQ, and that is known as two reaction theory. So go through page number 617 of PS Vimra, page number 622 of PS Vimra, and page number 629 of PS Vimra. You will get the concept of salient pole synchronous machine. Also you will get a phasor diagram as well as power equation, as well as the concept of synchronizing power. This is very important. Concept of synchronizing power is very important, so go through that. This is a basic concept. If you have understood the point number 1 to point number 13, then you can easily understand the salient pole synchronous machine. Okay, now the 15th point is hunting. What do you mean by this? Suppose a synchronous motor is connected to the infinite bus. Okay, and suppose any disturbance is occurred into the system, suppose a fault occurs or any disturbances occur, then the rotor angle as well as the speed of synchronous machine will change, means it will vary, means it will oscillate. So if I will make the waveform of delta, then the delta I will get something like this in transient state. This is the delta with respect to time. Also the speed I will get in transient state something like oscillatory. So because of any disturbance in the system, the rotor angle as well as the speed of synchronous machine will change. That is known as hunting. What are the effect of hunting? You have to understand. What are the causes of hunting? You have to understand, and how you can eliminate the hunting. So in order to prevent the hunting, or in order to decrease the hunting, what we will do the damper winding. So these all concept you can study from page number 647 in PS Vimra book. Now the 16th point is power flow diagram. This is very easy, because in DC machine also you have gone through the power flow diagram, in induction machine also you have gone through the power flow diagram. So same in the same way, you have to go through the power flow diagram of synchronous machine. You will get a concept in page number 661 of PS Vimra book. And the last is synchronous motor. You have to understand the basic concept of synchronous motor and about its stability, how the synchronous motor will behave in normal excitation, under excitation, and over excitation. These things you have to study, and you will get a concept in page number 676. So this much topic you have to study in synchronous machine, and I have given you the reference from where you have to study. You have to use both book, that is the DP Kothari and PS Bimra. Got it? Now I have gone through all the previous year questions. So what I will say, you should focus on basic concept first. This is very important. Then EMF equation under short pitch, then distributed winding, right? EMF equation in full pitch. These all things you have to study, because this is very important. Third is, this is armature reaction, that is a point number 3, is very important from gate point of view. Most of the question is asked from this. Equivalent circuit of synchronous machine, that is very easy. Phasor diagram is easy. EMF equation is formula, that I have already told you. This characteristics of synchronous machine, this is very important from gate point of view. Okay, point number 9, point number 10 is very important from this page. Point number 3, point number 8, point number 9, and point number 10 is very important from gate point of view. From this page, point number 12, point number 13, and point number 14, this is very important. Also you can consider point number 17, that is a synchronous motion, concept of synchronous motor. This is very important from gate point of view. So I have given you all the topic and the reference from where you have to study. Now it's your time to study. Today is 9th April, so you should complete this all topic, I think, within 7 days. So if you will start from 9th April, then you can easily complete this 17 topic on 16th April. Got it? So complete this all concept, and if you are getting any doubt, then you can ping me in Facebook group. You can send me the message, or you can send me the email to getmaticeducation@gmail.com. I will try to provide you the video lecture. But before that, I would like to tell you that I will not be present from 12 April to 12 May. I am going on holiday for 1 month. So what you can do, after completing this synchronous machine, go through the control system. Okay, that is available on Gatematic Education, that is control system. Whole lecture is available, so go through that. Also you can go through the power electronics. So do not wait for my video, because I will not be available for you. I will not make video for 1 month. I am going on holiday, so please do not wait, and try to complete a control system and power electronics in between 1 month. Video lecture is already available on Gatematic. YouTube channel. So you don't have to worry, only you have to follow the video lecture and you have to make the notes. After coming from holiday, I will give you the next strategy. That's all about this lecture. All the best. See you in the next lecture.